So hello students. So we'll continue again with topic number 2, that is cross drainage works. So cross drainage works. What are cross drainage works? Irrigational canals, while carrying water from headworks to crop field, have to cross few natural drainage streams, etc. So to cross those drainages safely by the canal, some suitable structures are required to be constructed. Works required to construct or to cross the drainage are called as cross drainage works, that is CDW. So what is the necessity of cross drainage works? The watershed canals do not cross natural drainages, but in actual orientation of the canal network, this ideal condition may not be available and the obstacles like natural drainage may be present across the canal. So the cross drainage works must be provided for running the irrigation system. At a crossing point, the water of the canal and the drainage gets intermixed. So for the smooth running of the canal with its designed discharge, the cross drainage works are required. So the site condition of the crossing point may be such that without any suitable structure, the water of the canal cannot be diverted to their natural directions. So the cross drainage works must be provided to maintain their natural flow direction. Next, types of cross drainage works. Number 1 is aqueduct. The hydraulic structure in which the irrigation canal is taken over the drainage, that is river and stream, etc., is known as aqueduct. This structure is suitable when bed level of canal is above the highest flood level of drainage. In this case, the drainage water passes clearly below the canal. So in this figure you can see the siphon aqueduct. Next, number 2 is super passages. The hydraulic structure in which the drainage is taken over the irrigation canal is known as super passage. The structure is suitable when the bed level of drainage is above the full supply level of the canal. The water of the canal passes clearly below the drainage. In this figure, you can see the super passage structure. Number 3, level crossing. When the bed level of the canal and the stream are approximately the same and the quality of water in canal and stream is not much different, the cross drainage work constructed is called as level crossing, where the water of the canal and stream is allowed to mix. In the figure you can see level crossing. Already about this aqueducts level crossing, these things we have already seen previously in our videos. So you can go and have a look at them again if you have forgotten. Next, selection of types of cross drainage works. The following factors should be considered. So the first one is relative bed level. According to the relative bed levels of the canal and the river of drainage, the type of cross drainage works are generally selected. Availability of suitable foundation. For the construction of cross drainage works, suitable foundation is required. By boring test, if suitable foundation is not available, then the type of cross drainage work should be selected from top of the site condition. Next, number 3, economic consideration. The cost of construction of cross drainage work should be justified with respect to the project cost and overall benefits of the project. So the type of work should be selected considering the economical point of view. Next, number 4, discharge of the drainage. Practically, the discharge of the drainage is very uncertain in the rainy season. So the structure should be carefully selected so that it may not be destroyed due to the unexpected heavy discharge of the river or drainage. Number 5, construction of problems. Different types of constructional problems may arise at the site, such as subsoil water, construction materials, communication, availability of land, etc. So the type of work should be selected according to the site condition. Next, waterlogging. Waterlogging. A land is said to be waterlogged when the soil pores within the crop root zone gets saturated and remains in this stage for a major period during the crop season. The groundwater level represents the level of free water surface within the ground and can be seen as the water surface in wells, rivers, ponds, etc. The waterlogging makes the soil alkaline in character and the fertility of the land is totally destroyed and the yield of the crop is reduced. What are the causes of waterlogging? The first one is over-irrigation. So in inundation irrigation, there is no controlling of water supply, so it may cause over-irrigation. The excess water percolates and remains stored within the root zone of the crops. Again, in perennial irrigation system, if water is applied more than what is required, then this excess of water is responsible for waterlogging. Next, number 2, seepage from canals. In underlying canal system, the water percolates to the bank of the canal and gets collected in the low-lying areas along the course of the canal, and thus the water table gets raised. This seepage is more in case of canal embanking. Number 3, inadequate surface draining. When there is heavy rainfall and if there is no provision for surface drainage, then the water gets collected and submerges a vast area. When this condition is continuous for a long period, then the water table gets raised. Number 4, obstruction in natural water course. If the bridges or culverts are constructed across with the opening with insufficient discharges capacity, then the upstream area gets flooded and this causes waterlogging. Number 5, obstruction in subsoil drainage. If some impermeable strata exists at a lower depth below the ground surface, then the movement of the subsoil gets obstructed and this causes waterlogging. Number 6, nature of soil. The soil having low permeability like black cotton soil does not allow the water to percolate through it. So in case of over-irrigation or flood, the water retains in this type of land and causes waterlogging. Number 7, incorrect method of cultivation. If the agricultural land is not leveled properly and if there is no arrangement of surplus water to flow out, then it creates pools of stagnant water leading to waterlogging. Number 8, seepage from reservoir. If the reservoir basin consists of permeable zones, cracks and fissures which were not detected during the construction of them, then this may cause seepage of water. This subsoil water will move forward towards the low-lying area and cause waterlogging. Number 9, poor irrigation management. If the main canal is kept open for a long time unnecessarily without computing the total water requirement of crops, then this leads to irrigation, which shall result in waterlogging. Number 10, excessive rainfall. If the rainfall is excessive and the water gets no time to get drained off completely, then the pool of stagnant water is formed, which might lead to waterlogging. Number 11, topography of the land. If the agricultural land is flat, that is with no slope, and if it consists of depression or undulations, then this leads to waterlogging. Number 12, occasional flood. If an area gets affected by flood every year and if there is no proper drainage system, then the water table gets affected and this causes waterlogging. So this is our assignment for lecture number 54. You have to write a case study about cross drainage works. Write a case study about cross drainage works. The date of submission is already mentioned here. Now we'll go through a video in continuation with all our previous classes. So that's all for this lecture. Thank you.
Same area, then this force will be there, and this is tau b into a, then weight component will be directly vertical, so there will be no component in that direction, and then the resistance force will be coming here. It is directly equal to W. Means basically if we make theta is equal to 0, then we get the expression for our expression will become, say, we can write it as W dash by A. We can write W dash by A, and then on the W dash by A, and then it is tan of phi. Okay. This part means W dash by A cos theta is becoming 0. Theta is becoming 0 means cos theta equal to 1, and then it become tan phi. And what about this part? When theta becoming 0, this part is becoming 0, and that's why it is 1 minus this means only root over 1. So finally this is becoming 1, and we get this expression. So this is what the expression 2. Now our target was to find an expression or to find a relation between the shear stress or unit tractive stress, attractive force at side and unit tractive force at bed. So we can now do 1 by 2. So that will give us, say, tau S by tau B. Tau S by tau B is equal to this, and that part will get cancelled, and we will be getting only cos theta, that root over 1 minus tan squared theta by tan squared phi. Well, so this is what very, very important expression that we use for design purpose. That's we use for design purpose. And then, as you can see, that cos theta root over this can further be simplified, but of course we are leaving it in this level, that is tau S and this ratio. This ratio has a particular name. We call this as a K. We call this ratio as a K, and then what we can see that K is equal to, say, tau S by tau B. This is equal to cos theta root over 1 minus tan square theta by tan square phi. That is name we are giving as K. And then one point we should note here, that theta will always be having some value, and of course for trapezoidal channel, and then this value will be always a fraction, I mean less than 1. So tau S is always equal to some fraction multiplied by tau B. Well, what it means, so this ratio we name as K, and so you can see that K is tau S by tau B and cos theta root over 1 plus tan square theta by phi. And more importantly, that when we see that cos theta, theta value will be always say a fraction. So it is between 1 and 0. So it will be a fraction, and I mean cos theta value will be a fraction. So the highest being 1.